Hello everyone, welcome to Learning Blockchain. In this tutorial, we will discuss about the membership service provider of Hyperledger Fabric blockchain technology. Its short form is MSP. So generally, whenever we start learning the Hyperledger Fabric blockchain, this is one of the confusing topic. People generally confuse that what is the membership service is all about and how all the cryptographic mechanisms actually performing behind. So in this tutorial, I will give a holistic view that how the folder structure present and how the cryptographic material actually talks to each other and what are the significance of different keys present over there. Kindly see the video till last so that you can get a fair idea about what the membership service provider in Hyperledger blockchain is. So let's start. So in the slide number 1, I gave a brief idea that what is the MSP all about and what is our confusion or what is our thought process. So generally, whenever we see the name like it is a service provider, we understand that it is a kind of service which actually doing some kind of cryptographic operations. But basically, it is not like a service like REST service or SOAP service or any kind of bootstrap service. It is a organized folder structure. So in that folder structure, each folder has different meaning, and that folder contains different private key and the public key of different cryptographic authorities and different nodes. So basically, this is the first thing you need to understand, that what is MSP all about. This is actually a directory structure, and each directory structure has different meanings. And whenever we are doing some kind of transactions inside the Hyperledger Fabric, we are doing some kind of validations, we are doing the endorsing, we are committing. So there are different terms that is already you are familiar with Hyperledger Fabric, I hope. If you are not, you can see my other video of blockchain basics where I have explained that what are the different terms of Hyperledger Fabric and how the total life cycle actually goes, so that how the Hyperledger blockchain actually commits the transaction and how it is endorsing the transaction and what are different things. So if you want to understand that part, so first see the blockchain basics, then come over this video. So first thing that I will assume that you have a fair idea, a little bit idea about how the Hyperledger Fabric blockchain works, and then you can start watching this video. So again, come back to the topic, like it is a MSP. So MSP is a directory structure, as I have mentioned, and this membership service provider actually have some ID associated with it. So generally in Hyperledger Fabric blockchain, whenever we give some kind of information of any of the entities, then we provide some ID and some associated information with it. So here each MSP is associated with one ID and a path, and that path actually represents a folder structure, in the directory. So once we go into the next slides, we will more understand that how this structure is and what are the meanings of different things. So I hope you have understood the first thing, that it is a directory structure and that directory structure is associated with one ID. Now let's move to the slide number 2. So here I have actually demonstrated like different parts, like different building blocks of the MSPs. So there are different types. First of all, there is a PR MSP, then there is orderer MSP, system channel MSP, and application channel MSP. So we know there are different building blocks present inside Hyperledger Fabric blockchain. Different nodes are works as a different things, like some nodes are peers, some nodes are orderers, there are channels present inside Hyperledger Fabric, and there are system channel and there are application channel. So each of the thing actually, how we can understand that if I submit some transactions, whether I am a peer or whether I am an orderer, or whether I am creating one channel and that channel needs some information inside it, that who can perform some kind of valid operations inside that channel. So that part is actually described by the MSP, and there are some mechanisms that how we can submit the transaction that I will describe later, that using the connection profile and the SDK layers, how the things are working, how we are picking up the MSPs and different things. So basically in this slide, just to get that idea, that there are different type of MSPs present, different nodes, different orderers, and the channels need to have some kind of information about all the cryptographic materials so that they can perform some operations, they can validate, they can authorize, they can endorse. Now, first of all, there is a PR MSP. So PR MSP is actually included inside base YML or core YML. As I have mentioned in my previous slide, that each of the MSP associated one ID and different paths of that particular directory structure. So PR MSP is described inside base YML or core YML. So I will not explain about the base YML and the core YML because it is outside the scope of this tutorial. You can go to the Fabric samples repository of Hyperledger Fabric, and you can see that how that YML structure is actually present. I hope I will describe these things in some other tutorial, but it is not in the scope of this tutorial. So next part, I have written some environment variables. So my main idea was that this particular MSP, that MSP ID and its path, its directory structure, can be represented inside the YML file, and also it can be overridden by the environment variable. So these environment variables actually, they like code PR local MSP ID and code PR MSP config path. This actually represents and overrides whatever is present inside the base YML or code YML. So in the base YML and the code YML, we have actually described the IDs and the path. And if you want to override it, then you can put it inside the environment variable. In the same way, orderer MSP's ID and the path is present inside the base YML or the orderer YML, and it also can be overridden by the some environment variable like orderer general local MSP ID and orderer general local MSP directory. Now there is next thing is the system channel MSP. System channel MSP is actually included inside the Genesis block. So system channel MSP I will describe in the next slide. Like there are different channels created that are system defined channel, like the orderer system channel. So orderer system channel actually needs to know what are different organizations are, what are the MSP IDs of different organizations, so that if anyone submits a transaction to the orderer, he can identify that, okay, so I already have this information inside the my Genesis block, that yes, these organizations are permitted and these are the MSP IDs, and there are different mechanisms are happening inside Hyperledger Fabric. So that is a separate thing, but definitely system channel MSP means it needs the first channel, that is the orderer system channel. One example, suppose they need to understand that what are the different organizations and their IDs are. So that is included inside the Genesis block. I will describe it into the next slide. Next is the application channel MSP. Application channel MSP means it is the user defined channel. Like whenever we create any Hyperledger Fabric network, we first need to create some kind of channel, and that channel configurations is present in a specific YML file that is called config.tx.yml. Okay. So in this config.tx.yml, I have given one code snippet just below it. You can see that there is organization, and there is a name of the organization like org1 MSP, and there is like ID org1 MSP and the MSP directory. So in this way, in the config.tx.yml, we provide that what are the organizations that are included inside this channel, because each channel needs to have some organization, like 2 organization creates one channel, 3 organization creates one channel, and they are participating inside it. So their information are already present in using one ID and the directory, that what are the directory present, but means where they will search for the keys and the different things. So this is the holistic view of the MSP type. Now next, move to the next slide. As I have told that there is a system channel MSP. So the first thing, whenever the network bootstrapped, then the first channel which is created called the orderer system channel. So orderer system channel, whenever it is created, another thing we need to know that whenever the first block is created, then it is known as the Genesis block. And if this Genesis block is being created as a part of the creation of a new network, means first time the network is being created, then this orderer system channel gets created the first time, the Genesis block. In other words, if the orderer being created will not be joined to an existing cluster of orderers. Means there are two different scenarios. Like whenever in the development mode we first creates the network, then the first time the orderer is getting created. And another scenario can be there is an existing network and I am joining as and different organizations in that particular network. Then I also suppose I'm also providing one sorry, I am also providing some orderer over it. That means in the ordering cluster is already present, and I am joining as organization, and I also have an orderer, and I want to join that particular network. That is a separate scenario. But as I have told, whenever it is first time created, then the Genesis block will be created. So the first time, this Genesis block will be the first block of the orderer system channel. A special channel managed by the orderer admins, which includes a list of organizations permitted to create the channels. So this line actually bears a lot of meaning. Like I am creating a new network, and in the network I need to have the orderer, and whenever the first time the orderer is being created, then Genesis block is created, and in that particular block we have to provide the information of all the organizations which are actually part of the network. So how we can give the information using the MSP? Like there will be definitely there will be names of the organizations, but MSP needs to be defined also, means the MSP ID at least. So in the right hand side you can see there is a code snippet of the core Hyperledger Fabric blockchain source code. You can see there is a MSP present. You can see there is a MSP present, msp.config. So we need not to understand this particular code snippet, but I have just pasted this code snippet so that you can get one idea that how whenever the first time the orderer is being created, the Genesis block is being created, how we actually point the MSP ID of that particular organizations inside it. And in the last block I have written the ordering system channel needs to define ordering parameters and consortium for creating channels. There must be exactly one ordering system channel for an ordering service, and it is first channel to be created, or more accurately bootstrapped. So as I have already described, you need not to understand much about it, but just in a brief you need to understand that whenever the first time the network bootstrapped, then the orderer needs to have the information of all the organizations, and that organization's information must include the MSP information also, that is the MSP ID. And this is the first block, that is called the Genesis block, and this block is the first block of the orderer system channel. Let's move to the next slide. How to generate the MSP certificates and their signing keys. So there are different ways that how we can actually generate these certificates for the Hyperledger Fabric blockchain network. So most famous is the Cryptogen. So whenever we starts with the development, then first of all there is a tool present with the Hyperledger Fabric blockchain technology, that there is a Cryptogen tool, and using the Cryptogen tool you can easily generate all the folder structure, all the hierarchical structure, etc. And there are different ways also, like OpenSSL can be used to generate the certificates and the keys. And also there is another concept called the Fabric CA. So Fabric provides one concept of the certification authority, and using that certification authority, definitely you can create all the keys. And one thing you need to remember, here all the certificates are of standard X.509. So X.509 is a specific standard which is being used inside the Hyperledger Fabric technology, and the keys are generally ECDS structure. So I will tell about it, but to explain the certificate structure and the ECDS structure, etc., is out of scope of this tutorial. So you can search in Google and you can get some idea that how the certificate structure is actually look like. And another thing I want to tell, like if you want to see the structure, then you can obviously use the Cryptogen tool and you can also actually create the empty structure using the Cryptogen generate command. So I will suggest that go over net and search for all the commands of the Cryptogen, and using Cryptogen you can create all the certificates. Also you can create the empty folder structure using the Cryptogen generate command. So these are the ways how we can actually create the all the cryptographic materials with the directory structures over there. Now, next point is the snippet of the Crypto-config.yaml. So, as I have told that using the Cryptogen tool, you can actually generate the certificate. This is one of the way which generally all the developers, whenever they are starting with their blockchain learning, they use it. So that Cryptogen tool actually refers to one of the YML file. So this YML file actually is very simple. It is very simple. I have written the code snippet of it. Like there are some tags present like order or orgs and PR orgs, and under that there is name, domain, and there are different options like enable node O's, means organization unit, and etc. So I just want to explain just a little thing over here, like the name and the domain. So whenever you specify, you write inside the orderer orgs this particular tag, then one name you have to give and one domain you have to give. This name and the domain actually will help you to create the directory structure. So according to this naming convention, the directory structure will be created. I will explain the directory structure in the next slide. So just now, just look into this file and you can see that the domain is very important, because using this domain name, the folder structure is being created. And there is another thing called the template. Template means there are users, there is one count, means this particular peer will have one user, and there will be one particular organization's folder structure will be created. Like there is a party a.example.com and the party b.example.com, and there will one user which will be automatically created if you use the Cryptogen tool, and that user is generally the admin. That I will explain, but do not need to confuse over it. Just to see the structure, that how the name and the domain you have to write, and according to this naming convention, the directory will be created. Just only these 2 points you just now you need to understand. And the users part, definitely the users part, like one user will be created by default with all the cryptographic element like the signing keys and the private key, public key, etc. So that will be created, just one. So let us move to the next slide. Now this is the MSP directory structure. This is very important. In the first picture, like this is the first picture where I am moving my cursor, you can see that crypto output. So crypto output or Cryptogen or Crypto-config, any folder that you can create using the any of the tools like Cryptogen or Fabric CA, or you can use OpenSSL, anything. So you have to create one folder, and under that folder, as I have told, there are two tags. As I have told, there are two tags. There is orderer orgs that you can see. There is orderer org, and another is a peer org. So the under crypto config or crypto output, there will be two folders will be created according to that. There is order organizations, and next will be the peer organization according to the naming convention. And in the left hand side, if you can see under the order organization, if you go, there will be another folder will be created, which will be the exactly the domain name which you have actually given inside that Crypto-config.yaml file. So under the order organizations, you can see there is a domain called example.com, and here exactly the example.com, this particular thing has been created. Now in the same way, inside the peer organizations, two folder structure will be created, because there are two organizations right now. We have given like party a.example.com and party b.example.com. So whenever I have created this thing inside my laptop, I have given the name as org1.example.com and org2.example.com. So exactly two folder structure has been created. So if you go inside any of it, like example.com or org1.example.com, org2.example.com, then you can see these folders in the last pictures. If you can see, there are different folders present like CA, MSP, orderers, TLSCA, users, and inside the peer organizations, each of the organization, if you go, there are different folder structures will be created like CA, MSP, peers, TLSCA, and the users. So I will explain each of the folder in the following video. Just keep watching the video. You will understand that what are the different folders are and how the structure actually goes. So I hope you understood the initial thing that these are the directory structure, and this directory structure is been referred by the path inside the base YML file or the environment variable, etc., etc. We actually give these paths, and these paths are related to one of the predefined path called fabric CFG path. So that is a separate thing. So fabric CFG path is one of the environment variable which we specify about our like the base directory, like from where you will start searching these relative paths, because in the base YML or the environment variable we give the relative path. So that relative path will actually has some kind of base directory. So that base directory is represented inside the fabric CFG path environment variable. So that is a separate thing, but for your information I told it. So let us move to the next slide. So this is the MSP directory structure. So MSP directory structure, if you see that there are different folders present in this slide, you can see CA, MSP, orderers, TLS, CA, users, and etc. So if you go inside the peers, then you can see there are another two folders has been created. One is the pr0.org1.example.com, and another point is the pr1.org1.example.com, because in the YML file we have written that there will be two peers for each organization. So this network is basically two org network, two organization, and that two organization will have two peers each. Okay, that is why whenever you will go to the peers folder, you can see there will be two folders. One is the peer 0 and another is the peer 1. So if you go to this peer0.org1.example.com, you can see there will be two directory. One is the MSP and another is TLS. Now inside this MSP directory, you can see there will be different directories and one YML file present. They are admin certs, CSRs, key stores, sign certs, TLS CSRs, TLS intermediate certs, and config.yml. Now I will explain each of the folder structure, that what they contain and what are the significance of each of the folder structure. Now let us move to the next slide. So in the next slide, before starting and before explaining each of the folder structure, because I have already given you the holistic view that how the folders look like. There are some base folders, and inside the base folders there are different folders and structures. I have already explained. So if you go inside these folders, then you will start to see different certificates. So I have just gisted over here three kind of certificates. One is the sign cert, another is the root cert, and another is the key store. So sign certs means it is actually public key to verify the signature of other entities. So basically Hyperledger Fabric works on the private and the public key infrastructure. So this PKI infrastructure means that you will sign one transaction or anything using your private key, and someone can verify that particular thing using the public key. So public key means it is already public, that you have given that key to anyone, and if they receive some signed transaction, then they can verify that particular transaction using the public key, that yes, you have written, you have signed actually this particular transaction. So sign cert is actually the public key. Next is the root cert. So root cert means public key of certificate authority who provides the sign certs for the nodes. So there are different certificates of the authority, someone is issuing me the certificate. I am a peer and someone is issuing me the certificate. So who is issuing me certificate? Some authority will issue me the certificate. So certificate authority will issue me the certificate because I am the peer, and that certificate authority has some kind of certificate because they are authority. They also need some kind of identification. How I will actually identify that that he is the authority? So they have some kind of certificates, so that are called the root cert. Next one is the key store. Key store, as I have mentioned, that that I have to sign using the private key. So I need that private key somehow present inside my folder structure, because I have to sign it. So whenever I want to sign, then I will use the key stores element, that is the private signing key. And in the next point, I have mentioned that the sars are X.509 standard and the keys are ECDS standard. So you can Google it and you can understand that what are the standards is out of scope of this tutorial. Now let us go over the explanation of each and every folder structure. So there are 5 folders, basically CA, MSP, peers or orderers, TLS, CA, and the users. So these are the first thing whenever you go inside the Crypto-config file, that is the first, the base folder. Inside that you can see the first this 5 folder structure. I am moving again. You can see whenever I am going to this particular network structure, you can see that there are 5 folders are present, like inside the order organizations or the peer organizations. Under that there are domain names, and inside the domain name there are 5 different folders, as in the last picture, as you can see. So I will start from there. The CA, MSP, peers or orderers, TLS, CA, and the users. Okay, so I am again recapping this particular picture for you. So let's move to this slide, like the CA folder. So what this the CA folder is all about? It has the root CA public key, which is used to issue the sign certs for the nodes. Okay, so it is the root CA public key. So as I have mentioned that each certificate authority also need to establish themselves as a authority. So they need some kind of information, that is the public key. And this CA, this certification authority, is actually used to issue the certificate for other nodes, for other peers, other orderers. Okay, so the, so in the CA folders, their authentication, the certification authority's public key is present over there. And it also has the private key of the CA, which is used to sign during the issue of the sign certs of the node. So first of all, I have to provide the signing certificate to the peers or the orderers. So I have to have the private key because I need to sign. And after that, the peer will have that signed certificate from the certification authority. So certification authority giving the authorization that yes, this is the peer, this is the orderer, and I have signed it. So someone wants to verify that okay, this is the peer and he has given, the certification authority has given some kind of information inside it. How I can verify? They will actually have the public key of this certificate authority, and they can use that public key of the certification authority to verify that yes, that authority has given the certificate to the node. So basically the CA folder contains the public key and the private key of the root CA. So how that mechanism occurs, I have already described. Now in the next folder is the MSP folder. So there is a base MSP folder. So in the base MSP folder, which also have 3 folders. So there are different MSP folders. As we will go inside the course, you can see that MSP named folder is present at different levels. So it is the first level. In the at the higher level, one MSP folder is present, and these MSP folders has the 3 different folders and one config.yml file in general. So admin cert folder will have a user certificate who will be the admin of the organization. This part is very important, admin of the organization. So this certificate will be present over there. Next is the CA cert. It will have the same certificate from the CA folder which we just saw above. So in the CA folder we'll have some kind of public key, and in the CA cert we'll also have this particular public key over there. Next is the TLS CA cert. So it will have the TLS root certificate which will be used when TLS will be enabled. We'll discuss more in the next slide. So just forget about it, what is the TLS and all about. Just one thing you need to understand, that CA cert will be used when the TLS is not enabled, and TLS CSRT will be used when the TLS is enabled. That is the transport level security. Transport level security is a specific protocol which is used whenever we want to ensure the security whenever the things are going over here and there from one party to another party. So this thing you need to understand. Next is the CRL. CRL is the optional, that is the certificate revocation list. So certificate revocation list means whenever I issue some certificate to someone, and after that somehow their certificate got compromised. So there can be one question that if somehow the certificate is compromised, then how you can ensure it. So basically this certificate never expires. This certificate never expires, and if you want to remove that certificate that somehow it got compromised, then you have to include that certificate inside the certificate revocation list, then that will be ignored. The last part is the config.yml. It is used to enable or disable the organization units. So this part I will describe later. I am not going into detail over here. Next, move to the next slide. The next slide is the peers and the orderers folder. So there are 5 folders as we have seen in the base. So this is the third one, that is the peers or the orderers. Inside the peers you can see the MSP and TLS. So again move to the picture. So this picture you can in the last one you can see these are the base folders like CA, MSP, orderers, TLS, CA, users, etc. And inside it, if you go to the peers, inside it you can see that there are different peers. If you have 2 peers, 3 peers, 4 peers, 5 peers, etc., each of the folders will be created with the peer 0 and peer 1 as your nomenclature defines inside the YML files. And if you go inside this peer, there will be 2 folders like MSP and TLS. So this MSP is inside the peer folder, and there is another MSP folder which is already present in the high level that we have already described right now. But this is the structure over here. So let us again move to that. So this is the MSP and the TLS. So these MSPs is actually, as I have shown, is present inside the peers, and inside the peers there will be peer0.domain name or peer1.domain name according to your nomenclature, whatever be the peer0, peer1 or ABCD, whatever you have given into the YML file. So inside that there is MSP and TLS, and inside the MSP here we have 5 folders and the config.yml file. So as we have seen into the base MSP folder, there was admin cert, CA cert, and TLS CA cert, CRL, and config.yml. But inside the peers MSP folder, we have admin certs, CA certs, sign cert, key store, TLS CA cert, and intermediate certs. So first of all, the admin cert means we'll have a user certificate which will be the admin of this user mentioned in the sign cert. So basically in the MSP folders, high level MSP folders, admin cert was the certificate of the admin of the organization. But here inside the MSP folder, there is one sign cert present. So one sign cert is already present. Sign cert, who has given the sign cert? Sign cert has been given by the certification authority to that particular node and for a particular user. So for this particular node, one sign cert has been given, and this particular peers admins, peers user certificate, peers admins user certificate will be present inside the admin certs folder. It may or may not be the admin certificate of the organization. It is the certificate of the sign cert, means there is some sign certs being present as I have told. So that sign cert, whatever certification authority has provided, its admin certificate will be present inside the admin certs folder. It may or may not be actual to the organization's admin. Next is the CSRT. It is the same. It is the same copy. It will have the same root certificate from the CA folder of upper level. So I am not describing it anymore. Next is the sign cert. As I have already told, the sign cert will have the peer certificate. So each peer needs to have one certificate which is signed by the CA root certificate. And again remember, these certificates are the public key. These certificates are the public key. So public key is used for the verification method. Okay. So whenever the CA actually issues some public key or the certificate that is present inside the sign cert, and it is a peer specific, and its admin cert present inside the admin cert folder. Now next point is the key store. So key store will actually have the private key of this particular peer certificate. So the sign cert is the base. So CA provides the signing certificate or the public key of that particular peer, and it is present inside the sign certs folder, and that's private key is present inside the key store folder. And whose signed certificate has been present, its admin means peer admin's certificate is present inside the admin cert folder. Next is the TLS CSR. It will have the root TLS CSR. So we will describe it like if you are using the certificate authority with TLS, means if you are enabled the TLS option, then this TLS CSR's certificate will be used to actually provide all the sign certs and etc. for verification. Next is the intermediate cert. So it is optional. Definitely it is optional. Whenever you will go over the development environment, it will not be generated. But as we know, like there is some root CA, and inside that root CA there can be intermediate CA. So there are different authorizations can present. Like you can think of a hierarchical signing structure. The first of all, if you need some permission, it needs to be signed by different levels of authority. Like there is some higher level of authority who will sign this particular authorization letter, and another person who is who works under him or her, he also signs it, and another person is works under the second person, he also needs to sign it. So something like that is the intermediate cert. So definitely to authorize a particular certificate, different hierarchical level of signing is required. So that is mainly the concept of the intermediate cert. So next point, like the TLS folder. So the last part is the TLS folder. It is also present inside the peers and orderers folder. So in the peers and orders folder, we have seen the MSP part. Now it is the TLS. So TLS will have the 2 certificate and 1 key. So if you have enabled the TLS, then I have told that there is one TLS CSRT is already present. So that TLS CSRT is already present at the higher level. It also present inside the peers folders MSP directory, and also it is present as a ca.crt. So ca.crt is one of the certificates. So this is the general name whenever you will use the Cryptogen tool. These are the naming conventions by which actually the certificates will be created. So ca.cert is none other than the same thing which is present inside the TLS CSR folder, the same public key. Next is the server.crt. So server.crt is the peer certificate but signed by the TLS root CA certificate. This is used when the TLS is enabled. It is similar to the sign certs folder content, but in case of TLS, this certificate is used instead of sign certs. So as I have told that whenever you will verify or whenever you will sign some certificate, then you will sign using your private key, and someone will have that public key of that particular of your public key they have, then they can verify using the public key that yes, you have signed this certificate. So that is the significance of the sign certs. So that sign certs is already present inside the MSP folder, as we have seen in the previous slide. Now the equivalent of sign cert is the server.crt. So if the TLS is enabled, then this server.crt will be used over there. Okay, the sign cert will not be used. This will be used. The next point is the server.key. So server.key is the private key. As we have seen inside the key store folder of the MSP directory in the previous slide, that there is one key store folder is present, which is actually the private key of this particular node. Private key of this particular node, because whenever you will submit some transaction, you have to sign that transaction using the private key. But if the TLS is enabled, then you have to use this server.key. This particular certificate will be used to actually sign the transaction. Let us move to the next slide. Now next slide is the TLSCA folder. So TLSCA folder is the higher level. So we have right now we have seen the 3 base folders. First one was CA, then there was let me go over there. Yeah, first one was CA, next one was the higher level MSP, the third one was the peers. As you can see, the third one peers, and inside peers we had already MSP and TLS. Now there are more two folders are present at the higher level, TLS, CA and the users. Okay, so right now we will describe about the TLS, CA and the users folder. We have already seen the description of CA, MSP, peers or orders. So let us move to that slide. So TLSCA folder, it is the same thing. It will have one certificate and the one key. It is the same as whatever present inside the TLSCA folder. So TLSCA folder will have the public key of the certification authority, and it is used whenever the TLS is enabled, and it contains the same thing as the CA cert present inside the peers orderers TLS folder, and it is the root CA certificate which is used to issue the signers of the nodes. The next part is the private key. The private key is the same thing, where the same as the server.key which is present inside the peers or orderers TLS folder. So as we have already described the TLS folder inside the peers and orderers thing in the previous slide, here it is same, like the same copy is present over here inside the TLSCA folder. Next is the users folder. So users folder, it defines different users for this particular peer or orderer. It has the same folder structure as peer and orderer folder. That is, it contains two directories, MSP and TLS. So users folder is a separate folder which is present as the higher level, and it contains the same structure as the peers. So inside the peers folder, we have already seen the MSP and TLS, and I have described it. Inside the users folder also you will see one folder like admin dot something, admin dot example.com, and inside that you can see the MSP and the TLS folder, and it contains the same information. Now suppose one important thing, you will see the admin search folder inside this users folder. So that admin search folder will have the public key or the signing certificate of the user. So suppose you have given the username as user1. So in the admin search folder, if the same certificate is present, that is user1 at the rate org1.example.com, because he is the admin of its own user. Why it is the admin of its own user? That means that inside the admin search folder, if you somehow put some certificates inside the admin search folder, then Hyperledger Fabric internally assume it as the admin. That okay, if something is present inside the admin search folder and something is present inside the sign search folder, so sign search folder is actually is your key, and if something is present inside the admin search folder, then that particular key has the admin right. So if you sign some transaction, if you are doing some transaction which requires admin level of access right, then if your certificate is present inside this admin search folder, then you will be considered as the admin, so that you can perform the admin related transactions over there. So users folder is nothing but the similar structure inside the peers folder, but it has the user specific information, because a single organization can have different users and different users can have different access rights. So that's the thing which is present inside the users folder. The next point is the certificate revocation list. So as I have told that it is important to note that MSP identities never expire. They can only be revoked by adding them to the appropriate CRLs. Additionally, there is currently no support for enforcing revocation of TLS certificate. So right now there is no support to revoking the TLS certificate, but non-TLS certificate definitely you can do it in the certificate revocation list, and you can put it over there. But as we know that Hyperledger Fabric version 2.0 already established, and it is already present inside the latest tag, and we hope into the future versions maybe there is a revocation of TLS certificate will also be enabled. Now MSP identity validity rules. So MSP identity validity means like suppose like there is some root certificate and root certificate can issue the certificate to the peer. So root certificate is present inside the root, that is the CSRs folder, and the certificate which he has issued is present inside the signcerts folder. Now we have also seen there is intermediate certification, intermediate certificate authority. So this diagram, if you follow this diagram, then you can understand more that how the intermediate certificate authority works. That root CA provides some certificate to the ICA, that is the intermediate certificate authority. Intermediate certificate authority can have different hierarchies, and via signing all these things, finally one ID has been issued. So root can directly issue some ID, or root can actually provide the certificate to intermediate certificate authority, and intermediate certificate authority can subsequently provide it to other intermediate certificate authority, or can provide the certificate. So let us see that in the diagram beside, only certificates signed by ICA 11, ICA 12 and IC signed by internal nodes will be rejected. Okay, so you can see that ICA 2 issued the ID, ICA 11 issued the ID, ICA 3 issued the ID, RCA 3 issued the ID over there. Okay, so only these certificates are valid. So right now, if RCA1 issuing some certificate and that network structure has some intermediate certificates, then that certification will be rejected, because whenever you will verify the certificate, you will search for the sign of root certificate, intermediate certificates and all other. So finally, who is actually giving the ID depends on network to network, depending on your cryptographic architecture, that which certificates you will actually allow. So this particular thing actually present. Now like one example, if you can see, like if a certificate C is signed by ICA or RCA, for which an organizational unit has been specified in the MSP configuration, then C considered valid if among other requirements it includes OU string as a part of its OU field. So right now we are moving a little bit deeper, like we have explained the node OUs part. There is enable node OUS. If you can remember, there was one part inside the crypto config file. So we are gradually moving to that particular part. Maybe that is the last part. So it is actually want to say that if there is node OUs enabled is present, then if the certificate authority has the OU field, then in your certificate, whatever be the certificate is being issued by this certificate authority, that must contain that organization unit field. For example, if you can see the admin cert, owner, that is CN is means common name is admin@org1.example.com. So basically this is the structure, this is the structure of the admin certificate, this is the decoded structure, that what is present inside the certificate. So inside the certificate it is present that OU is manufacturer plus OU is equal to client, and there are different information about the country, state, locality, and this is the owner certificate. Owner means I am the peer, I got the certificate. I am a user, I got the certificate. This is the certificate of that. Next part is the issuer. Issuer means who has issued the certificate. So if you can see, this is a certification authority. So issuer is the certification authority. So issuer, if you can see, there is a OU field. OU is equal to manufacturer is present inside the issuer. So if this issuer is issuing some certificate, then this OU field with the exact value must have to be present inside the certificate. So this is all about this. Okay, so I hope you have understood this slide. So let's move to next slide. Now is the OU and identity validation. This is the config.yml. So as we have told that there's enable node OUs, like enable node OUS, one field is present which is true or false. So if you are making it like a true, then you have to provide this YML file, that is the config.yml. So inside this config.yml, what you need to say that MSP, so let me explain this thing, like MSP implementation allows the organizations to further classify the identities into clients, admins, peers and orderers. An identity should be classified as a client if it transacts on the network. Okay, an identity should be classified as an admin. It handles the administrative tasks such as joining a peer to the channel or signing a channel configuration. An identity should be classified as a peer if it endorses or commits a transaction. So that is why more granular level of classification is present now, supported by Hyperledger. That yes, you can specify different certificates as different roles, like clients, whether it's a peer, whether it's admin, whether it's an orderer, different things. Now in the this section, like some code snippet I have given, that you can see that this is the nomenclature, this is the tag that you need to write it, like client OU identifier certificate. The certificate is the relative path which is present, that are all the PAM files. So PAM files are the public keys. And another is the organizational unit identifier, that is the client. So organizational unit identifier is the most important tag for this classification. So I am just explaining the sample of the config.yml file. If you can remember, there was another thing present inside the MSP directory, that is the config.yml. That is optional. If you write the enable node OUs as true, then you have to provide this config.yml file, and you need to mention that okay, for this particular user or for this particular peer, how it will work, whether that peer will work as an admin, this user will work as an admin, or it will work as a client, or it will work as a peer. So these are all the information, either one you have to specify over it. Like in the last line I have mentioned the admin OU identifier field, it is the explanation over there. This means that any certificate issued by the certificating authority for your organization which contains an organizational unit is equal to admin is now considered as an admin. So if the certification authority have given you the certificate, and that certificate has the OU field, and that OU field has the value as admin, OU is equal to admin, the certificate contained, then you will be considered as an admin if this node OUS is enabled and config.yml file is correctly configured. If node US is enabled, is true, and you are not providing this config.yml file, then that will be ignored. So this is one of the important part that you need to understand. Okay, so this is the means main significance of this config.yml for the more granular level of classification. And using the certificates, just using the certificate, you can specify whether that particular certificate can be a admin or a client. So we know that if we put the certificate inside the admin search folder, then it is a admin. But apart from that, if you provide the OU field is equal to admin inside the certificate, that will also be considered as a certificate regardless it is present inside the admin search folder or not. Okay, so let us move to some of the best practices. So I hope you have understood the structure of the MSP services. So that's all for the structural part. Now we will see some of the best practices of the MSP when we will design your architecture. The first thing what I will recommend, definitely there is a one-to-one mapping. Like if you have one organization, then make one MSP. Okay, so one-to-one mapping will be the best practice, like one organization one MSP, one organization one MSP, something like that, one to one. And some other thing you can definitely do, but that will be a difficult from the security perspective also, and also the maintenance perspective. Like one organization can have multiple MSPs, and multiple organization can have one MSP. So both can be possible, but best is one to one. So definitely try to implement one to one. But this thing you can explore that how the things are working and how you are handling it. The next part is the one organization has different divisions, say organizational units, to which it wants to grant access to different channels. So all members one MSP or each division one MSP. So all members one MSP is my specification, because as we have seen that I have different divisions, like OU is equal to manufacturer, OU is equal to producer. So different OUs part are present, but from the MSP perspective, you can use one MSP also. Okay. Next is separating clients from peers of the same organization. Yes, definitely. This is one of the important thing, that you have to separate the clients from the peers of the same organization. And the next part is the admin and the CA certificate. Create different certificates for different level of MSP. Example, trust of root, intermediate CS, etc. So different certificates. So you should not use the same certificate as the root CA and the intermediate CA both. Definitely you have to use different certificate for the intermediate CA and the root CA. So that is just different thing, like different level of MSP. And because you should not use the same certificate, definitely. And the next is the blacklisting and intermediate CA. Do blacklisting whenever needed. So this is basically one advanced topic, that intermediate CA, this is from the business and the functional perspective, that if the intermediate certification authority is somehow malfunctioning, or they are not trustworthy, or you are changing the organizational label and use some different certificates, then you can blacklist it. And next is the CS and the TLS CA. Keep different folders for CS certificate and the TLS certificate, that we have already used. We have different folders for the CS certificate and the TLS certificates, because the TLS CA is the different folder and normal CA is a different folder. If the TLS is enabled, then the TLS CA folder will be used, and if the CA is not enabled, then the CA certificate is used. So that is the basic thing, that if the TLS is enabled, then the TLS CA and the corresponding different folder certificate will be used, and the normal CA and the sign certs, that part will be ignored, as I have described already. So we are already practicing this. So these are one of the some of the best practices which is present inside this Hyperledger Fabric, and you must have to follow it if you are going to build one very good architecture. So that's all for today. I hope you have get some kind of idea of the membership service provider, that how things are working, what are the directory structure, and how different things are working. So just the last thing I want to tell, that you are wondering that how this MSPs is actually used to sign the transactions, and how the things are doing. So basically it is using the connection profile and the API layer, that is the SDK layer. So whenever we created this crypto configs and the cryptographic materials, we created the channels, deployed the chain codes, and etc. Then actually we have to create the middleware, that is the API layer. So API layer is used using the SDK Fabric SDK part. So Fabric SDK are provided in different languages, like Fabric SDK Go, Fabric SDK Java, Fabric SDK Node, and they actually use some connection profile. So that connection profile has the path, means this cryptographic folder we will also need to be present inside that API layer, and that API layer will actually refer to that cryptographic materials, use the connection profile, and inside that Fabric SDK the code is written somehow like that, that whenever you are submitting the transactions, then you are actually following the connection profiles, you are getting to the path. So and then actually you are reading the certificates. So Fabric SDK actually sees the connection profile, and using the connection profile they get identification of the path, that where the cryptographic materials are stored, and from there they are picking up the cryptographic materials, and then they are using the code, they are signing it, and after that they are submitting it inside the blockchain network. That is how actually this MSP things, the signing things and the submitting thing works. I hope you have liked the tutorial. If you want to see more this kind of tutorials, then please subscribe to our channel, and also like and share the video as much as possible. Thank you. See you in next lecture.